Hello student, welcome in Rose project. दया शिक्षण संस्था सातारा, सद्गुरु गाडगे महाराज कॉलेज कराड with 12th Rose project 2021-22 presented by Katkar Priyanka Sham. My subject is physics. Topic number 9, current electricity. Current electricity. In that fourth lecture, we will see the point of potentiometer, study of the potentiometer, application of potentiometer, in what way we can use potentiometer. We will study in that lecture. First lecture content. Method first, to find internal resistance of cell, application of potentiometer, voltage divider, audio control, potentiometer as sensor, advantages of potentiometer over voltmeter, merits and demerits. In that lecture we will see method second, to find the internal resistance of this cell, application of potentiometer, voltage divider, audio control, potentiometer as sensor, advantages of potentiometer over a voltmeter, and merits and demerits. First, to find internal resistance into bracket small r of a cell, we have to find the internal resistance of this cell. So this is the method second, application of the potentiometer second. First application earlier we have already studied into the back lecture. In that lecture we find to find the internal resistance of this cell. Here diagram shows internal resistance of this cell. Okay, here in figure 9.10 internal resistance of this cell, we will see two key K1 and K2. Two keys are connected in series with the resistance. Here first a potentiometer of wire which is starting varying from 1 meter to 5 meter. Here A and B are the two terminals of the wires which is connected to the long table. Okay, here copper strips are used for the connecting the two strips. Here A and B are the two terminals of the wire. Okay, then EMF which is connected positive and negative terminals. EMF is connected in series with the key K1, and variable resistors, that is rheostat, is used to the connecting K1. Fixed terminal of rheostat is connected to K1. Another fixed terminal of rheostat is floating, and the variable terminal is connected to the point B. Variable terminal is connected to the point B, and it is again connected to the whole wire is connected to the A, point A. So here P, T and S, P, Q are S. P, Q, here S and T are the four quadrilateral point. P, Q, S and T are the four quadrilateral point. Here E1 is a first EMF and R is a internal resistance. E1 is a first EMF, R is the internal resistance, and in series with that EMF R is connected. So K2 key is connected with the resistance capital R, and it is connected to the Q point, and from the another terminal of the Q there is galvanometer is connected, and positive terminal of the galvanometer is connected to the jockey. Over the jockey we can, with the help of jockey we can vary the point. At one point we will get a deflection which is called as length L1, and another, when L1 is calculated then we will get L2 by differencing 400. Okay, that is when we tap the jockey in that wire, then at one point we will get a deflection. At one point we will get deflection, and that deflection is equal to L1, and 400 minus L1 is equal to second length L2. We will get that length. Okay, with the help of jockey we will get that length. So this is the arrangement of the internal resistance of this cell. Then second, to find the internal resistance of the cell, in that the experimental setup for this method consists of potentiometer wire AB. The experimental setup for this method consists of potentiometer wire AB connected in series with the cell of EMF E. Connected in series with the cell of EMF E. The key K1 and rheostat as shown in figure. Key K1 and rheostat as shown in figure. The terminal A is at higher potential than terminal B. Here terminal A is at higher potential than B. A cell of EMF E1 whose internal resistance R1 is to be determined is connected to the potentiometer wire. Through the galvanometer G and jockey J, we will get the particular point. Okay, so first main important aspect of that practical of the potentiometer. A terminal A is at higher potential than terminal B. Okay. A resistance box R is connected across the cell E1. Resistance box R is connected across the cell E1 through the key K2. Resistance box is connected across the cell E1 through the key K2. To find internal resistance of the cell, the key K1 is closed and K2 is open. The circuit now consists of the cell E, cell E1 and the potentiometer wire. The null point is then obtained. Let I1 be the potentiometer wire between the null point and point A. I1 be the potentiometer wire between the null point and point A. This length corresponds to EMF E1. This length corresponds to EMF E1. So E1 is equal to K into L1. E1 is equal to K into L1, where K is a potential gradient of the potentiometer wire, which is a constant. Now both the key K1 and K2 are closed such that circuit consists of the cell E, the cell E1, the resistance box, the galvanometer and the jockey. Some resistance R is selected from the resistance box and null point is obtained. The length of the wire L2 between the wire L2, the null point and point A is measured. To find internal resistance of this cell, here V is equal to K into L2. So E1 divided by V is equal to KL1 divided by KL2. Therefore L1 divided by L2 are the length. Consider the loop PQSTP. In the back circuit diagram we have to consider the loop PQSTP. E1 is equal to IR plus capital IR plus small IR and V is equal to IR. So E1 divided by V is equal to IR plus capital I into small r divided by capital IR. Therefore, into bracket capital R plus small r bracket complete divided by R is equal to L1 divided by L2. So small r, internal resistance of the cell, is equal to small r is equal to capital R into bracket L1 divided by L2 minus 1. This equation gives the internal resistance of the cell. With the help of that equation, we can find out the internal resistance of the cell. Here is animation. With the help of animation, we can find out the expression for the potentiometer as the various type of the finding internal resistance of the battery using a potentiometer. Finding internal resistance of the battery using a potentiometer. This is the one animation. With the help of animation, we can find all aspect. To find out the internal resistance of an unknown battery using the potentiometer. Here figure shows on the table there are potentiometer are kept and potentiometer is connected. 4 meter wires are connected in between the terminal A and B. Here is at terminal B, battery is connected to the power battery is connected. Negative terminal of the battery is connected to the one point B. Negative terminal of wire is connected to the one point B, and A point is connected to the EMF E, then resistance and internal resistance. Okay, so we know that the formula here, capital R is external resistance. With the help of color coding line or ring, we can find out the value of the resistance. Here two tap keys are connected in series. Two tap keys are connected in series with the two-way keys, and by combining two-way key, one wire is giving outside, and this will be connected to the negative terminal of the galvanometer, and positive terminal is connected to the another arrangement. Okay, positive terminal is connected to the jockey. Student can give the vertical reading at the various aspect of the length. Okay, by touching the jockey, we can find out the reading into the galvanometer. Okay, current is flowing from the galvanometer. I is equal to 0. When current is flowing from the galvanometer, current is flowing from this wire, different types of the deflection we will get. Here jockey, with the help of jockey, we can find out the length L1. Okay, here current is flowing from the wire first. In that animation way, we can find out the different types of the practical experiment also. Okay, current is flowing from the wire. Okay, current is flowing from the wire. Then we will get one reading. AP1 is equal to L1, AB is equal to L0. Therefore, potential drop across AB is equal to V0. Potential drop across AB is equal to V0. So V is equal to V0 into I divided by I0. V is equal to V0 into I divided by I0. Therefore, E is equal to V0. E is equal to V0 into L1 divided by L0. L1 divided by L0. Okay, this is the particular arrangement. With the help of equation, we can find out the EMF. Then next our point P2 will be getting at the length. Then we will get the equation. Okay, what will be the equation? Next equation is V is equal to V1 divided by I1, V1 into I1 divided by I2. So this is the second equation. Okay, with the help of that equation, we can calculate the potentiometer. Okay, so this is the application of the potentiometer, finding out the internal resistance of the battery. Next, potentiometer is used as voltage divider. Potentiometer is used as voltage divider. Here is a diagram which shows voltage dividing. With the help of potentiometer, we can divide the voltage into the middle point of the wire. Here EMF E is connected positive, negative, and R resistance is connected. Then EMF is connected in series with resistance R. Then point A and B. Here is a point A and B. In between point A and B, point P lies. So AP1 is equal to L1, PB is equal to L2. Then potential difference in between A and B is a V2 is equal to dV divided by dl into bracket capital L minus L1 bracket complete. So V2 is equal to dV divided by dl into bracket L minus L1. So AB is equal to L and AP is equal to L1. So PB is equal to L minus L1. Then potential gradient V1 is equal to dV divided by dl into L1. So this is the voltage divider arrangement of the potentiometer. Okay. Application of potentiometer. The potentiometer can be used as a voltage divider. The potentiometer can be used as a voltage divider to continuously change the output voltage of the voltage supply. As shown in figure, a potential V is set up between point A and point B of the potentiometer wire. One end of the device is connected to positive point A and other end is connected to the slider that can move along the wire AB. The voltage V divides in proportion of length L1 and L2 as shown in back figure. Then we can use potentiometer as audio control. With the help of potentiometer, we can less or we can higher the maximum value range. Then with the help of potentiometer, we can getting the variation of the frequency with the help of that potentiometer. Okay, so potentiometer act as a audio control. Sliding the potentiometer are commonly used in a modern low power audio system as a audio control devices. Sliding the potentiometer are commonly used in a modern low power audio system as a audio control devices. Both sliding and rotatory potentiometer are regularly used for frequency attenuation. Attenuation means changing in the frequency level from higher to lower value. With the help of potentiometer, we can attenuate the frequency. Then loudness control, and for controlling the different characteristics of the audio signal. For controlling different characteristics of the audio signal, we can use the potentiometer. Potentiometer as a sensor. In different types of the laboratory, we can use a potentiometer as a sensor. Sensor means if the slider of the potentiometer is connected to moving part of machine, slider of the potentiometer is connected to the moving part of machine, it can work as a motion sensor. A small displacement of moving part causes change in potential, which is further amplified using an amplifier circuit. What is mean of amplification? Amplification means we will strengthen the signals from lower value to higher value. Amplification means strengthen the signal from lower value to higher value. So the potential difference is calibrated in terms of the displacement, the moving part. The potential difference is calibrated in terms of the displacement of the moving part. Advantages of potentiometer over a voltmeter. When we compare the voltmeter and potentiometer, bigger advantages of the potentiometer as compared to voltmeter. That is merits of the potentiometer. First merit, potentiometer is more sensitive than voltmeter. Potentiometer is more sensitive than voltmeter. Second, a potentiometer can be used to measure potential difference as well as an EMF of cell. A potentiometer can be used to measure potential difference as well as EMF of cell. Then voltmeter always measure terminal potential difference, and as it draws some current, it cannot be used to measure an EMF of cell. Voltmeter always measure terminal potential difference, and as it draws some current, it cannot be used to measure an EMF of cell. Third, measurement of potential difference or EMF is very accurate in the case of the potentiometer. A very small potential difference of the order of 10 raised to minus volt can be measured with it. 10 raised to minus 6 volt is equal to 1 microvolt. Okay. Least count of the potentiometer is much better compared to that of the voltmeter. Least count of the potentiometer is much better compared to that of voltmeter. What are the demerits of the potentiometer? There are some demerits in case of the potentiometer. In various types of the application, we can use potentiometer, but there are some defects produced into the potentiometer that can be find out the demerits. Potentiometer is not portable. Potentiometer is bigger in size, so it is it not portable? It cannot be portable or vary from one place to another place. We cannot transport that potentiometer, and direct measurement of the potential difference or EMF is not possible. Okay, thank you. This is the lecture number 4. Thank you.